Hi everyone, my name is Ming Khan. Today I will be talking about my master's first year research project where I hope to quantify uncertainties in the fossil record, recorded stratigraphic ranges in the paleobiology database, and the senior ellipse effect as applied to studies of extinction selectivity. Extinction selectivity seeks to understand why, in the light of crisis, certain taxa go extinct while others survive. Its quantification can help us understand diversity dynamics during background and mass extinction intervals and predict which taxa are most at risk today. Extinction selectivity is generally measured on ecological and physiological traits, such as whether a taxon is benthic or epibenthic, large-bodied or small-bodied, has a wide geographic range or a narrow geographic range. In my project, I am assessing geographic range and body size. A current limitation of extinction selectivity is that we take recorded stratigraphic ranges at face value. However, the senior ellipse effect tells us that the youngest known fossil occurrence is only an approximation of the actual last occurrence date. Therefore, incomplete sampling can make catastrophic extinction events look like gradual declines. Over Phanerozoic time, stratigraphic sampling has not been uniform. The probability of observing an extinction event is linked to the completeness of our sample. This means that in intervals showing low fossil recovery rates, our observation of extinction events is also reduced. We propose using capture-mark-recapture methods to assess extinction selectivity. In ecology, CMR methods are used to assess population parameters from multiple sampling events. In paleontology, the first occurrence of a taxon is analogous to marking, and every subsequent occurrence is analogous to recapturing. Within CMR, in the Praedel seniority model, parameters include the survival probability, that is, the chances of a genus that is extant in one time bin persists to the next time bin. The seniority probability, that is, if a genus is present, the probability it was extant in the preceding time interval, and the sampling probability, which is the completeness of taxa within a time bin as well as the time bin as a whole. We are trying our Praedel models on geographic range and body size datasets once we have access to high-performance supercomputers, as we have over 700,000 observations. No matter what the method of assessing extinction selectivity, we need to test for its rigor. For my master's project over the next 5 months, we plan to assess our methods through simulations of the fossil record, where we will randomly assign traits of size and range to every simulated genera. In our first scenario, we will generate random extinctions and sample the dataset fully and subsample with decreasing fossil recovery potential. We will assess 3 selectivity models: logistic regression, linear regression, and CMR methods. In our second extinction scenario, we will have size-biased extinctions. That is, we will generate scenarios where larger taxa or smaller taxa preferentially go extinct, or narrower taxa versus widespread taxa preferentially go extinct. On each scenario, we will repeat our subsampling metrics of fully sampling and decreasing fossil recovery potential. We will empirically determine which selectivity model most accurately represents the fully sampled datasets to understand which method is best. As this is an ongoing project, I am looking forward to any suggestions you might have. Thank you very much for watching.